Hello everyone, my name is Vijay Ramareddy and my registration number is 251FB04039. Today I am going to present a topic from operating systems called process management, and I am here to explain how an operating system manages programs when they are running. This topic is very important because it explains how the CPU handles multiple tasks efficiently. Introduction to the operating system. An operating system or OS acts an interference between the user and the computer hardware. It manages all hardware resources such as CPU, memory, and input-output devices and ensures that program runs efficiently. One of the most important responsibility of an operating system is process management because it is directly controls how programs are executed by the CPU. What is a process? A process is a program that is currently under execution. A program becomes a process when it is loaded into memory, it is assigned CPU time, it is given system resource. Unlike a program, a process has a current execution state, allocated resources, control information. So, whenever a program starts running, it becomes a process. Program versus process. Let us understand the difference between a program and a process. A program is a passive entity, stored on disk, has no execution state, does not use resources. A process is an activity entity, resides in memory, has an execution state, and uses CPU, memory, and I/O. In simple terms, a program is a recipe and a process is a cooking. Process states. During its lifetime, a process moves through different states. The main states are new, ready, running, and waiting. For new is a being process. Ready, waiting for CPU allocated. Running, currently executing. Waiting for IO or some event. Terminated, execution completed. These states together form the process life cycle. Process state transition. The operating system continuously switches process between the states to use the CPU efficiently. For example, a running process moves to waiting with a request IO. After IO completion, it moves back to ready. This continuous switching allows the system to perform multitasking. Process Control Block (PCB). For each process, the operating system maintains a data structure called the Process Control Block or PCB. PCB contains of process ID, progress counter, CPU register, process state, scheduling information, memory management information. The PCB acts like an identity card for the process, storing all essential details. Context switching. Context switching occurs when the CPU switches from one process to another. The steps involved are save the state for the current process in the PCB, load the stored of the next process for the PCB, resume execution. Although context switching is necessary, it introduces overhead because CPU time is used for switching instead of execution programs. Program scheduling. The operating system uses CPU scheduling to decide which process gets the CPU, for how long it gets the CPU. The main goal for the scheduler are maximize CPU utilization, reduce waiting time, improve system responsiveness. This ensures fairness among all the resources. Process was thread. A process is a heavyweight entity, has separate memory, slower to create. A thread is a light unit of execution, shares memory with other threads, faster execution. Modern application uses multi-threading to improve performances. Let us take a real-time example. Consider opening a browser, a music player, a code editor. Each application runs a separate process. Inside each process, tasks like tabs, songs, or backgrounds operations runs as threads. The operation system manages all of them simultaneously using process management techniques. Importance of process management. Process management enables multitasking, efficient CPU usage, system stability, fast application response. Without process management, modern operating system would not function smoothly. In this presentation, we discussed about what a process is, process states and life cycle, process control block, context switching, difference between process and threads. These concepts forms of core foundation of operating system. To conclude, process management is a critical component of an operating system. Understanding this topic helps us to know how modern system executes multiple programs efficiently and reliably. Thank you.